Okay, let's look at question number 18. This is a slightly more complex question. All right, I think, can you see that to get this area, to get the area of the triangle OAC, OAC, all right, I think you need to calculate this length OC, and then can you see that this is the perpendicular distance? Therefore, once you get your OC and once you get your AE, you can calculate this area. And then after that, once you get this area, you just multiply by 7, and then you are done. All right. Okay, and to solve this question, let me complete the so-called the square. Let me complete the square here. All right, let me complete the square here, and then you can extend. You can extend all the way here, and then I call this point G, or I call this point G. And take note that OD to DB is actually 3:1. And it is given that OB is actually 40. OB is 40. All right, therefore this part is 30, and then this part is 10. And then this part here, the length is 40. All right, okay. And okay, I think our job here is to get AE first. I want to get the length of AE. See whether I can get the length of AE. Right? Okay, therefore, I think I want to introduce this angle, theta, right? And then this angle would be 90 degrees minus theta. Right? Yeah. Okay, and in this case, can you see that this is also 90 degrees? And this angle here would be theta. Therefore, I think with that, you can actually prove for yourself that triangle DOE, DOE is similar to triangle triangle DAO, DAO. Right? That means basically I'm talking about this triangle similar to this triangle. This one. I think as I highlight, you know which are the triangle that I'm looking at. Right? And in this case, can you see that DE, DE is to DO. DE is to DO. All right. Can you see that this part here and this part here and DO. All right. DE, this one, this distance and this distance, they are similar. And this is the same as DO over DA, hypotenuse, the hypotenuse. Then in this case, can you see that we calculate DE, and then DO is actually 30, right? Can you see that DO is actually 30? From here to here, this is 30. Therefore, you get 30 squared. And then your DA, okay, DA, can you look at DA? Can you see that you have this right angle triangle here? This is 30, this is 40. This is your DA. All right, and then this is 90 degrees. Therefore, I think you can see that by Pythagoras theorem, this will be 50. Therefore, this part is 50. And in this case, can you see that your DE would turn out to be 80? Would turn out to be 18 or 18. Therefore, AE, can you see that AE is actually 50 minus 18, and that will be 32. Therefore, I got the objective. I know the length of AE. Therefore, that's very good. Then after that, I think I want to prove to you that, okay, let me clean this part off so that the diagram will be a bit clearer. Then I think I want to prove these two triangles are congruence. Congruence. That means in this case, can I look at GOB? That means this one, this triangle, and the other triangle, DAO. Therefore, let me just highlight this one here, this one. That means in this case, I want to prove that these two triangles are actually similar, congruence, not similar, congruence, right? Therefore, can I say that, okay, can I say that this part here, GOB, that means in this case, can you see that this angle and this angle are the same? I think this one established from the previous part, theta. I think in the previous case, we already established that, right? And then after that, can you see that OBG, that means this is 90 degrees, And can you see that this part here, this is also 90 degrees, all right? Yeah, okay. Then I think in this case, the length here, or this length is equal to this length, right? Or therefore, we can conclude that triangle GOB is actually congruence. This one means congruence. Congruence to triangle DAO or DAO. And can you see that this is angle, side, angle? Or that means in this case, can you see that angle here, and then there's a side here, and then there's an angle. Or therefore, in this case, I'm using ASA property, right? Then on top of that, now let me clean this part here. Let me clean this part. And now I want to prove that this triangle BGO, this triangle, and the other triangle OCA, this triangle, these two triangles are similar. Quite obvious. That means in this case, can you see that this angle is equal to this angle, vertically opposite, and then this angle here is equal to this angle here. Therefore, they are similar. Right? And in this case, I can prove that triangle BGO, right? BGC, sorry, this is C. BGC is similar. It's similar to what? It's similar to triangle AOC, right? Therefore, in this case, can you see that BG over AO is just equal to what? BG, Okay, take note, because these two triangles are congruent, therefore we notice that this is 30, therefore this part here has to be 30. Therefore in this case, BG, this is 30, and then this is 40. And then this would be just equal to 3 over 4. Therefore, because congruence, therefore this is 30. We know that this part here is 30. Take note that this part here is 30, therefore this part here has to be 30. Congruence triangle. That means this part, I think I want you to take note that BG is equal to DO and is equal to 30. Right? Equal to 30. Right? Then in this case, can you see that now? Look at it this way. That means this is 3:4, right? 3:4. That means in this case, I just want you to realize that this is three portion. This is actually 4 portion, right? Therefore, this is 4 portion, and then this is 3 portion. Therefore, this part here is 4 portion. Take note that this is 4 portion, and then this part here is 3 portion. Therefore, I can say that OC is actually 4 over 7 of OG. And we know that OG is the same as DA, congruence triangle. Therefore, take note, OG is same as what? OG is same as DA. AD is same as AD, and that will be just equal to 50. Right, therefore this will be just equal to 4 over 7 times 50. And then in this case, can you see that this would be 200 over 7. Right? And we know that, okay, we know that the area of the triangle OAC, as I explained at the start, it is equal to what? It is equal to half OC multiplied by OE. Therefore, let me clean this part again so that you can see properly. Right, therefore, let me clean this part. Therefore, I already said the area of this triangle, it is actually OC times the perpendicular distance. This is perpendicular distance. Right, and OC now, can you see that this is 200 over 7. And times AE, times AE. Okay, this part here, this is AE. Right, and AE is actually 32, right? AE is 32 here, right? Therefore, in this case, can you see that basically you get 3200 over 7. Therefore, 7 times of this area, OAC, that will be just equal to 3,200. Therefore, the answer is just 3,200. Right? Okay, I think with that, I can stop here. Yeah.